Hey guys, so another one here today. Wait a second. Let me make this bigger. Alright. Okay. Real quick, factors affecting solubility. Kind of just summarize things we've talked about. And I just posted bookwork too that basically is some stuff we've already gone over, and then I basically have gone over everything with this. This would be like 5-6 minute video, just real quick reviewing. So factors that affect solubility. So remember, solubility is how much you can dissolve at a certain temperature in a certain amount of water. So if you want to add more solute to the same amount of water, what you can do is if you increase temperature on a solid solute, that equals an increase in solubility. And again, we've already gone through these things. I'm just summarizing. So increased temp, solid solute. And so if you heat up the water, you can add more solute in the same amount of water. All right. But if you want to do the opposite, if you decrease the temp on gas solute, that's going to increase solubility of the gas. Okay. So gases want to be cold. That's the opposite. If I decrease temp, and we talked about table G with all this past couple days. So that's the opposite. The other thing you can do is, well, basically these are the two big ones. I don't want to confuse you, but those are the two big ones as far as increasing solubility with the same amount of water, right? So this is not changing. So same volume of solvent, right? If you add more water, then of course you can add more solute, right? So if you have, if you have a beaker with water and you have a little bit of water, and then you have a beaker with a lot of water, obviously this one, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so the dots are solute, right? So if you have a little water, you can add solute, a certain amount, whatever that is. And there's ways to figure it out, table G and all that. But if you add more water, solvent, then of course you can add more solute, right? So that's a little different, but that's something else you can do. You can increase the amount of solvent. And one thing I wanted to talk about, two things. Really, surface area is the biggest one. Now, surface area does not change solubility. Does not change solubility. If something is going to dissolve, it will dissolve or it will not dissolve. Increasing or decreasing surface area does not change that. All right, surface area, and what I mean by surface area is a couple things. Crushing something into a powder or stirring. Right? So if I have a big chunk of something and I smash it into all these little pieces, right? So now I have little pieces. This has low surface area, this is high, right? So if I add a chunk of sugar or salt to water, or I add powder sugar and salt to water, this here, high surface area, will dissolve faster. That's the key. The rate of dissolving increases, meaning it'll dissolve faster. Think about if you're making Kool-Aid or putting sugar in coffee or whatever, making lemonade, iced tea, whatever analogy helps. When you stir it, it dissolves faster because what you're doing, crushing chunks into powder, stirring a solution, does that same thing. It increases surface area. Particles are now spread out, very small particles, so water can attack that quicker and dissolve it faster. So this was kind of my last thought here today, that surface area I hadn't really talked about. If you increase surface area by crushing it into a powder, grinding it, stirring it, the water will break it down faster because more of the particles are exposed, right? If you have this chunk, the inside of this chunk may be dry. You put that whole chunk in water, water eats away at the outside. It's going to take a while to get to the inside. But if you crush it, now all the particles are exposed, even the ones that were in the middle. That's why it dissolves faster. And in the science terms here, rate of dissolving increases, rate meaning fast, speed, right? It'll dissolve faster, quicker if you stir it or crush it, because there's more surface area now attracted to the water, forming those forces of attraction to create a solution. All right, so that was the last thing. It does not mean you can add more, right? So if I have 10 grams of this and 10 grams of that, and I can't add any more, well, I can't add any more. It doesn't matter if I crush it. The solubility is what it is. You can only dissolve a certain amount, and the rest will just sink to the bottom. So crushing it doesn't mean you can add more. It just means it dissolves faster. All right, that's it. See you guys.